Hi, everyone. My name is Alok Pattani. I'm a data science developer advocate here at Google Cloud. And I'm excited today to talk to you about data science at scale using R on Google Cloud. I'm a big fan of R. And one of the things I wanted to learn when I started working at Google Cloud is how to scale it up. So this talk will be talking about various ways to do that. Just to go through what we're going to cover today, we'll start with an introduction, data science, R, and Google Cloud. What are those individually? And then how we're going to talk about them collectively. Then we'll go through a couple different Google Cloud products and how they work with R, starting with BigQuery, moving on to cloud storage, and then using R Jupyter notebooks on AI platform. Finally, we'll go through an exciting demo that puts it all together and shows how you can start answering your own data science questions using R on Google Cloud. So first, let's get an intro. So data science is a term that has been defined by lots of different peoples in lots of ways. So let's talk a little bit first about how we define that. This is a diagram taken from Hadley Wickham, who's one of the best R developers and data science folks working today. He talks about the different aspects of the data science process. You start with where you have importing data. Then you do a lot of work to maybe clean the data, pre-process it. That can be called tidying the data. That might be into a tidy format, which is one observation per row, or just tidy in sort of the colloquial sense. Then before you go to sort of model it, you might do some transformations. Transformations includes things like bucketizing your data, creating some pre-computed calculations, things like that. Then you'll visualize to maybe study some of the relationships in between your variables, exploratory data analysis, that sort of thing, before you proceed to this modeling stage. And then the reason this is in a box is that this stage is pretty iterative. You might create a model, realize you want to go transform one of your variables in a different way, visualize a different relationship, think about things differently, go back and model, and you'll iterate through this process a lot. And then finally, we'll communicate. One thing I want to mention, especially given that we are in the prepare stage of the ML Summit, is that modeling, though often gets the most attention and fanfare, well-deserved sometimes, there's some really cool things that come out of modeling, we don't always spend the most time on this. A data scientist who's trying to understand insights, trying to understand relationships between things in their data, and thinking about what they should go back and recollect, will spend a lot more time in these sorts of areas: import, tidy, transform, visualize. So in today's talk, I actually won't focus as much on modeling, and I will focus more on the other aspects of the data science process in R as enabled by Google Cloud. Let's take a step back and talk about the R programming language. Some of you may be familiar with this, but just to make sure, R is a programming language that's widely used for data analysis, statistical computing, visualization, and more. Part of what makes it so accessible and exciting to work with is that there's a large active community of data science and data scientists and machine learning professionals who work on R and contribute many different packages. You see there's over 15,000 on the comprehensive R archive network and many more on GitHub, which can extend the capabilities of R. When I started using R over a decade ago, in school, I was thinking it was just for statistics. That might have been closer to true then, but now it's for many more things. You can scrape data. You can visualize different data. You can create animations. You can create your entire websites and apps in R. So this is why it has gone from sort of this niche language to one of the more popular ones. The tidyverse is a set of packages developed and maintained by mostly people at RStudio, which those R users are familiar with, as a company that provides one of the most popular interfaces for R. And those folks have made this set of packages and an ecosystem around them that have truly enabled more efficient analysis and easier sort of time to analysis for first timers. And that has really exploded as well over the last 5 years. R as a language. So again, not to, maybe if you're in this talk, you already know this, but R is one of the most popular languages across all of the languages, not just for data science. It was the 6th ranked language in the IEEE Spectrum 2020 rankings, ranked in the top 10 for languages in demand by employers and for enterprise applications. The TIOBE index, which is a little more month to month has ranked R ninth and up 10 spots from a year ago at this time. Another report says that it's the fastest growing language worldwide, at nearly doubling the number of users. So I don't want to, ignore the elephant in the room. Python is by far the most popular language and has a ton of capabilities for data science. On the other hand, it's not a zero-sum game. You can learn R, you can learn Python, you can learn how to use them together and the best of both worlds. As you can see, R is growing pretty fast and has a huge user base as well. So this is why I, personally coming from an R background, but also want to make sure that people understand we can use R for a lot of different things, and it's a deserving language in the data science community. All right, so let's talk about Google Cloud. Now, Google Cloud generally solves many different problems, right? Not just data science, but what does it mean for data science? Technically, we're just trying to get insights from data, right? So how do we do that? And what you'll see here is we have Google Cloud hardware. You have a bunch of hexagons that represent Google Cloud software products, and that is what represents Google Cloud. So it's the combination of compute and tools to access that compute that allows you to do scalable data science. More specifically, we have data warehouses, we have tools for analytics, and tools for machine learning. So Google Cloud encompasses way more than, again, R or any particular language, but the idea is it's a set of tools that can help us do our jobs. So now let's put this all together. So this we'll stay on this slide for a little bit here. What are the Google Cloud tools that help enable data science? So there are many more than the ones I've shown here, but the three that I'll cover in this talk are BigQuery, our relational database product, cloud storage, which is the storage section of Google Cloud, and AI platform, which is our artificial intelligence, machine learning set of tools that can be used to do that sort of analysis. We'll also talk about R and Jupyter notebooks. For those of you who are familiar with Jupyter notebooks, who aren't familiar, with Jupyter notebooks, it's a way to run interactive data analysis where you can embed code, text, and outputs all together. It's been super popular, again, over the last decade or so for Python users, R users, and even those in other languages. It's super cool. We'll do a demo later, so I won't belabor the point right now. How do these different tools map to that data science process we were talking about? So cloud storage is a good place to store data, so you might import from there. You can do tidying in BigQuery or in R. Same thing with transformation of data. Same thing actually with modeling. BigQuery has some modeling that's outside the scope of this talk, but we can talk about this. And then AI platform also used for modeling, AI platform for visualization, communication. There are actually many different tools here. I put cloud storage because in some cases what you might do is create an output from R and put it back on cloud storage to be shared more widely. And all of this process can run in a sort of a Jupyter Notebook environment. And that's what we'll demo at the end here. So you can see how these tools come together. We're not going to cover all capabilities of all tools, but we'll try to hit on what each tool is useful for and how it all kind of works back with R. All right, so first we'll talk about BigQuery in R. Okay. BigQuery is Google Cloud's enterprise data warehouse for analytics. And the key here is that it allows you to work with humongous data, gigabyte to petabyte scale storage and SQL queries. When I first got to Google and then when I then moved to cloud, being able to use SQL to analyze literally billions of rows, sometimes trillions of rows of data was amazing. It scaled up my analysis. It allowed me to do way more than I ever thought was possible. And a lot of this was empowered by BigQuery and sort of the underlying technology. It's fully managed and serverless. In other words, you don't have to decide how many cores or computers, clusters, et cetera, to run it. All you have to do is write your query and it will do the rest for you. It's encrypted, durable, and highly available. Over here, I've shown just a small example. We have a public data set of natality data on births. I picked out a few columns. And, it's a simple SQL query to extract some data. But you can see right here, it actually processed 5 gigabytes of data. And that's not a joke, under 1 second. So this is a really powerful tool you want to use in general. And you can see why it's useful to use it with R, because R in memory, especially not on your laptop, you don't want to be loading in billions of rows of data and then filtering. You probably want to use BigQuery to do some of your initial pre-processing and filtering, and then read stuff into R. So you can see here the sort of scale and speed of BigQuery. Okay, so let's talk about how to use BigQuery with R. So thanks again to the RStudio team, in particular, Hadley Wickham and Jenny Bryan, and others who have worked on this. There is a third-party package called BigRQuery. And what it does is allows you to use BigQuery with R. And the way you do this, and I have some example code here, again, we'll show a little bit in the demo, is you need to load this package, the BigRQuery package, provide your Google Cloud Project ID, which if you're using Google Cloud, you would have. You write your SQL query as text. So here again, it's the same query I just showed in the previous window, pulling out a few rows, few fields from natality data and limiting to 10,000. And then you use this BQ table download, BQ project query. Now, the first time you call this within each session, this is again an example from RStudio. It's different if you use notebooks. We'll go over that as well. It'll request an access to your Google account, and you can authenticate interactively via the browser, or you can use out-of-band authentication. Basically, BigQuery needs to know who you are before it returns the results to R, and there are different ways to kind of set that up. But it's managed fairly well by the BigRQuery package. Once you do it once, you're pretty well set up to do it many times. And then, once you kind of authenticate here, it'll say, look, we ran this 5.6 gigabyte query. We got 10,000 rows. And then here's the sort of top of that data set, what it looks like. And here at the bottom here, there's a link on GitHub, tinyurl.com/BigQuery in R. This just shows you this code in case you want to use it to get started. It's sort of the minimal example of how to get started with BigQuery in R. Next up, let's talk about cloud storage. Okay. So cloud storage in general is a powerful, simple, and cost-effective object storage service, has low latency and high durability. This is essentially where you want to store all sorts of input files, structured, unstructured. From a data science standpoint, the ones that I use it most commonly for are CSVs, JSON files, things that contain data that has not been loaded yet into something like a BigQuery, or even in like some more unstructured things, video files or audio files, where you're going to do some other processing before you even get to sort of the more straightforward data analysis pieces. The other side of things is cloud storage is a really good place to store analysis outputs. So for example, you may do some things, and again, we're talking a little bit more about interactive data analysis and data exploration than modeling. But what you might generate images, you might generate HTML outputs, you might generate GIFs or something, and even more these days we can do animated plots and things. This is a good place to store them. You can store them in different buckets, you can title them in different ways, and make them accessible to your collaborators or to even a website, even to the public. So I have two different examples of Google Cloud Storage buckets here that I've used in the past. One of them is similar to the use case we talked about, or the first one, input file. So I have some data, it's eval data and training data. This is probably set up for machine learning use case where I need to train on one set and then evaluate on another. You can see the size there. And again, it's just CSVs. On the other side, I have this soccer analysis we did with penalty kicks. This is the results of analysis done, where it generates an HTML sort of interactive plot. And you can see actually these have been set to be public to the internet. They're a little bit bigger than kind of fit in a generic drive situation. So by putting them here and then having this URL public, you can then pass it on, embed it in different things and that sort of thing. So this is another really good use of cloud storage for the purposes of data science. Okay, so then just like we did with BigQuery, we talk about BigQuery and then BigQuery with R. Let's talk about cloud storage with R. So to get this set up, again, the first time takes a little bit of work, but after it's set up, it will work really seamlessly. So You activate the cloud storage JSON API that allows basically your Google Cloud project to be accessible, the cloud storage within your project to be accessible via R. You create a service account and you download a file with authorization credentials. Here, I've called that file cloud storage auth file. That would be some sort of parameter in your R code. And then, thanks to this package, Google Cloud Storage R, this was developed by one of our Google developer experts. What you can do is you set this environment variable before you load the package, which is the GCS auth file. Then you load the package. What it will then do is basically take that key file and then allow you to access Google Cloud Storage. So again, each time you'll need to read this in, but once you do it once within your script, you're kind of good to go. And then here, the example I took is like, let's say we took that data, those 10,000 rows we had downloaded from BigQuery, and we did something that's very typical in R. You create a histogram using ggplot, right? And you look at the histogram, and you say, oh, that's interesting. I want to save that plot out. So in the sort of non-cloud workspace, you might save it to your desktop and then upload it somewhere. Here, the idea is you can upload it right to cloud storage. So again, it can be accessible for other people or for yourself down later. So you use ggsave as you traditionally do to kind of save this, and then upload it here to the specified bucket with the specified file name. And what you'll see here is that it'll come back telling you exactly where it is. And this shows you that this is actually the image of that graphic within the cloud storage browser, where you can preview graphics of certain types. So again, set it up once, and then now you have this way to interface with Google Cloud Storage from R, just like you did with BigQuery. All right, so now we're going to get to those are more running R with Google Cloud. Now we're going to get to running R on Google Cloud, and we're going to do that using our Jupyter notebooks on AI Platform. So what are AI Platform Jupyter notebooks? So if you're familiar again with Jupyter notebooks, interactive notebooks where you embed code, text, and outputs all together. Really good way to do exploratory data analysis and sometimes share your results with others where everything is all there for them to see. They can rerun themselves. There are many different services that do this, including Google has its own Colab. These, the notebooks we're going to talk about today, are managed Jupyter Lab notebook within Google Cloud. And what that means is you can configure the backends, you can kind of pre-set up the different libraries that you want in there, and then they're kind of always available. You can spin them up and shut them down as you'd like to kind of scale up your workflows. We have Python and R notebooks. Of course, in this talk, we'll focus on R notebooks, but Python notebooks are very useful also. The R notebooks are pre-configured with popular data science libraries. So that would include things like the tidyverse, which we talked about, BigQuery, TensorFlow, which is obviously very popular for machine learning these days, and other cloud-related libraries. Beyond that, you can still install the other ones, and I'll show in the demo how we do that. And then this is kind of what it looks like. So you can see here we have an R sample instance, R 3.6. You open Jupyter Lab, and I'll show you. The really cool part, and this is where I think once you get familiar with this, where you will find this very useful, is that you can configure the memory of these, the sort of the VMs behind, the virtual machines behind these notebooks. So you can get up to, make sure you need this before you get it, but terabytes of RAM and many, many CPUs. You can run parallel processes. These are really useful for high-level model training, but not just that. Again, we're going to talk about cases where you might use R to kind of call BigQuery, but you need to call BigQuery many times, or you need to generate not just one plot, but maybe hundreds of plots that all kind of go in this similar way. And it might take a really long time on R on your laptop to do this. If you use a R AI Platform notebook, you can, and with a high memory backend, which again you can configure up and down, you might be able to take this thing that takes hours and do it in minutes. And of course, that's the name of the game these days. Okay, so what does an R notebook look like? Again, this is just example screenshots. We'll do more in the demo. What you have here is that same SQL query that we had looked at in BigQuery, but this is in an R notebook cell, so we pass it in as text. And just like we did in the R Studio, our snippets that were from our studio, We pass it over to BigQuery project query. We download the table. We look at the data. The difference here is that it shows up right below this code cell in a notebook. Then we take that data, we do a plot, and again, it shows up right below. So again, this is the type of thing that I, at least in my experience as a data scientist, have done a lot, right? Explore data, call some stuff in, look at the top of the table, maybe look at some distributions, and then we go forward with lots of stuff. But you know, again, that iterative process, you go back and say, okay, now let's get another data set. Let's look at another field. Let's look at a different set of data across a different time span or a different, other parameter. And Jupyter Notebooks can make that whole process very sort of integrated and reproducible, seamless. All right. Now let's put it all together and do a demo. So, like any good demo, we want to start with at least a reasonable analysis question, like any good data science demo. And in this case, what I'm going to talk about is which professional athletes are the most popular among fans on a daily basis. So I'm a big sports fan, so this is why I picked this topic, but I want to make it clear. I think this could be useful in many different contexts. And the way we're going to go about it is using a BigQuery public data set that has hourly Wikipedia page views. So as you know, Wikipedia, sort of an online encyclopedia, a very popular place to go and learn about different things. And, more credit to them, they've made a lot of their page view data open, and credit to those working on the BigQuery public dataset program. They have already loaded this into BigQuery for us, updating sort of daily with actually hourly page views. So the one thing to note here is that these page views, this is screenshots from the BigQuery table. The size of this table in BigQuery, and this is just the 2020 page views, is over 1.7 terabytes and 42 billion rows. So you really don't want to read this entire data set into R as is. You want to do some pre-processing in BigQuery, but then you may want to, you may get it down to a manageable level where you want to start doing some analysis in R, whether that be using dplyr to get some summary statistics, ggplot to do plots, or more. So this is a fairly straightforward data set. It has the hour. It has wiki, which is kind of the language, I think it's the language, and then also like a difference for mobile and desktop, as well as the page title and then the number of views. So again, I'm going to pick athletes, and we're going to start with an exploratory analysis of 2 athletes and then try to scale up to more. But imagine that you're trying to gather information on time series for anything. So it could be 2 different products, political figures, TV shows. You pick your sort of industry use case. The idea here is that Wikipedia gives you a really interesting data set into what people are looking at on a daily basis, in this case, hourly. And we can use it to do time series analysis, at least exploratory time series analysis, in this case in R. So let's start this demo in AI Platform Notebooks. We'll click here. Okay, so there's a couple different instances. Here you see Python, and this is the one that I've already pre-configured for our session here today. You can see that the default standard is 4 virtual CPUs and 15 gigabytes of RAM. You can do this using new instance. I've decided to splurge today and go for 64 virtual CPUs and 240 gigabytes of RAM. Because there's one step where I really want to show that I can run a bunch of things at once. So if we open Jupyter Lab, all right, you'll see that I already have pre-populated some code here, but I will restart the kernel so that we're not cheating here. So again, this is a Jupyter notebook, and we're going to put together a bunch of pieces we talked about here: BigQuery, cloud storage, and then pieces of R that really shine: visualization and interactive analysis. So in this case, I've loaded this cloud storage authorization file here because it needs to be available to this notebook sort of on the virtual machine that it's powered on. So that, again, goes back to that first step we talked about with cloud storage, setting up the service account. So once I do that, so again, you can run cells using this or control this little button or control enter. So I'll run that cell. Now we're just talking like R code. There's a couple of packages that were not available by default that I have installed on this particular kernel. It doesn't take very long, but I don't want to spend time doing that now. So I've left that the code, but those are the three that I had to do. And then these are the different packages we will use. Some of these are more generic R packages for data processing. Future and fur are really useful for multi-threading, which is what we're going to take a look at today. And this is a timing package. These are our two packages we talked about, BigQuery and Google Cloud Storage R, that enable the different pieces of Google Cloud to work well with R. And then these are two packages I really like for sort of interactive data analysis. DT is data tables package, which allows you to make these interactive outputs that you can sort and filter. And then Plotly is a popular plotting package for both Python and R that allows interactive graphics and a bunch of other things like that. So when I run this cell, it runs fairly quickly. Again, we're fortunate because most of these packages are already installed here. Then the next step is to make sure I'm set up for BigQuery. So in this case, we use this out-of-band authentication, and you just do that with BQauth. So you use out-of-band authentication equals true. And we'll set this project ID. We don't have to set this here, but we reference it later. So I like to keep that in a constant up top. All right. Now let's get to the fun part, which is to do the actual analysis. So when I have a question like this, I like to start with maybe one or two examples, and before we start scaling up and really like reading in all these gigabytes of data using BigQuery. So two athletes that are pretty prominent at the moment are LeBron James, a very well-known NBA player who's playing in the NBA Finals for the Lakers, and Patrick Mahomes, the defending Super Bowl MVP, and he just got a really rich contract in the offseason, and he's off to a really good start in this NFL season as well. So we're going to start with those two. We're going to read their Wikipedia views on a daily basis, and then see what we learn, and then maybe think about what we could do with more. So this is now, some of this is our code. I won't go into detail, but just setting it up. The Wikipedia pages will look more like this with its first name underscore last name. We do some lowercasing to handle titling. You don't want to deal with title issues. LeBron has a capital B in his name. Now we'll get to the SQL query. So again, we're going to work off that BigQuery public data set on Wikipedia page views. We'll do some filtering we'll aggregate to the date level. We don't need the hourly for this particular instance. We'll look at English pages and again, filter to the first 9 months of this year, 2020. And we'll use this little formatting parameter here to show you how we're going to pipe in that we want these two athletes into the query. So this is a tactic I use a lot. Use R or Python, but in this case, again, R, to write the SQL for me. Because in some cases, I don't want to run one query. I want to run many queries, right? And then I want to bring in the data in an organized fashion. I can't bring it all in. I can't group in SQL. It might be something that I really need to bring in the data in this different, like, chunked fashion. So in this case, what you do is you write a SQL query, and then I left the parameters for what are the names you want to filter. So in this case, we'll filter to LeBron James and Patrick Mahomes. All right, so now we run the query using, again, BQ project query and then BQ table download from the big R query package. It will take a couple seconds, pretty fast. Again, that table has 1.7 terabytes of data. Because of partitioning, we don't end up scanning all of it, but you do scan a good bunch of it. So that's pretty impressive. We already bring it into R. And now you can see on the daily basis, some of the views. So on September 30th, LeBron James had many more page views on Wikipedia than Patrick Mahomes did, but the opposite was true on the 29th and the 28th. LeBron was ahead on the 27th. You can see, if you know anything about sports, this actually has to do with who was playing on which day. On the 28th, Patrick Mahomes was playing in a Monday Night Football game. On September 30th, LeBron James is playing in a finals game. This actually makes sense. People are going to look up those athletes when they are maybe watching them or seeing what they're doing on the internet, social media, things like that. So this just gives you the sort of first 10 rows of this table. But let's see what happens if we use, again, that DT package to get a data table from that same data set. So just by putting in this little bit of code, and again, we're within our same notebook, we now have an interactive data table. So it's a little bit hard to see here, but on this side, we have the page views, right? And now we can sort by views and see who had the most views on any one day. So that's interesting. There was one day in February where Patrick Mahomes had way more views than either of these folks have had on any day. And if you know, again, you're a sports fan, this was the day of the Super Bowl, and he was playing in the Super Bowl. And that makes sense. It's the most popular sporting event in North America, one of the most popular sporting events in the world. He was one of the star players in that game. Makes sense. And this is the day after the Super Bowl. These are other days of his game. And you can come up with sort of news explanations for why this is the case. But again, you can sort here. You can do some filtering. This gets really cool when you have multiple columns. You can add logos here. DT is a super cool R package for this and works really well within notebooks. Okay. But again, we want to get to visualization too. So now let's talk about this. We got some idea here of the day by day, but this is 548 rows. I want to get an idea of which one of these guys is more popular in terms of Wikipedia views over time, this entire year. So what we'll do here is use ggplot, which is a tremendously popular package for plotting in R, and we'll create this sort of scatter plot by date. We look at the views and we color by whether it's LeBron James or Patrick Mahomes. Again, I won't go through all the code here. Some of this is just to get the date labels right, etc. One key, though, is that using the plotly package, which you mentioned earlier, we can turn this plot into an interactive one. So that's by you simply take the ggplot object, you pass it to ggplotly, and you'll get an interactive plot. All right, so it takes a second to load because it is a nice high fidelity HTML plot. But what you can see here is that now we've taken our sort of regular scatter plot and turned it interactive. So we have red for the Chiefs for Patrick Mahomes, and we have purple for the Lakers for LeBron James. You can see that there's one day that clearly stands out. That's that Super Bowl that we talked about. But let's say we filter to kind of the last couple months here. So we can pick a window, right? And it will automatically resize it for us. And what we can see here is that, in fact, and we'll try this a little bit too. Yeah, so we get our scale back. So there was a few days in July where Patrick Mahomes had more Wikipedia page views, but actually for most of this time, LeBron has been slightly more popular. And then again, we see these peaks. These are football is played more regularly than basketball. So every time Patrick Mahomes plays, it seems like his page views go up and surpass LeBron's, but otherwise he's ahead most of the days. And then, so like you can imagine spending a lot of time going through this, trying to understand things. Again, understanding the data before we start extracting these features, you might think about what we want to do here is predict these people's page views or predict which one of these guys is going to be more popular for certain things. And again, think about it in a different context. It's not just athletes. Athletes are a fun toy example. But we'll study this plot. We can think about seasonal patterns. Should we, do some time series decomposition, these sorts of things? Should we extract some aggregates, those ideas? So here, and again, double click. So you can see that, there's some different patterns here. LeBron may be ahead most days, but when Patrick Mahomes has his peak days, they're really high peaks. All right, so I like this plot, at least as an initial case. And now I want to share it with someone. Maybe, or just save it off so that I can look at it later. So what we'll do here is 2 steps and use cloud storage, the Google Cloud Storage package that we talked about. And we'll save it. This is traditional sort of plotly way to save off an interactive plot. And then we will upload it to Google Cloud Storage here with the particular cloud storage bucket that we have pre-set up in this case called R demos. So if we run that, it'll say, we stored it, etc. And then if we go over to our demos, so I'll go back one step. This is the storage bucket, and we can put the URL. And now we have this sort of stored off for other people outside of our notebook, right? So in our notebook, we shut it down or move on, do something else. We don't save the output. We have this available. It has all the same interactive capabilities. So slipping back over to our notebook here. All right. So don't want to take up too much more time here, but I will show this. I'm not going to run just in case it takes a little bit longer than we want, but this is how we can really scale up. So we did something on 2 athletes. Now let's say we think that that's pretty interesting. What we want to do is do this for more than 2 athletes and more than just this year. Okay, so these are some options here that I play with in the future package. And this allows you to access the sort of multi-core capabilities that you set up when we configured this notebook. So by setting up that there's 64 cores and doing this plan multi-process thing, which is tied to the future package that we talked about, what we can do is scale things up. So first, let me set the context. What I have over here, and again, this is a CSV I loaded into this environment so that it can be accessible to the notebook, is a bunch of athletes ranked by YouGov, which is a service that does polling to determine how sort of well-known a person is. They do it interactively. They have a nice list. Let's say I want to take their list and then look up Wikipedia page views for everyone. So here's a list of the top, I think I have the top 100 here, athletes by their list. And this could serve as sort of the basis for how we want to, the list we want to use to read the data from BigQuery. So if you look here, this kind of now sets this up for our reading into BigQuery. If you think of each athlete in the row as a row, and then each query we need to run as a row on the athlete and year, what we're going to do is set up a data frame that tells you how many queries and which ones we want to run. So here's the initial data frame with the athletes, and then we use the page title. We use some text manipulation to get it in the form of the Wikipedia page titles. There's a little bit of an extra ad for Carlos Santana, who's a baseball player. We don't want to look up Carlos Santana, the musician, for this purpose. And now what we will do is create a query template. So it's similar to the way we did it before, but what we'll do is kind of put in these brackets around variables in strings that we can then replace with different fields, right? Because in this case, we're not just going to pass in one name or 2 names. We're going to pass in 25 names. An in statement is fairly inefficient, and in some cases the query may take a long time. So what we want to do is maybe parallelize the queries. In this case, what we do is we pass in the page title as a parameter here, and then the year as a parameter in a couple spots here. So there's Wikipedia page views going back to 2015. So we pass that as a parameter here, here, and here in the date filtering. And then what we do is we still aggregate. So for each year, for each athlete, we will get the sort of Wikipedia daily page results, similar to what we got for Patrick Mahomes and LeBron James, but we'll get them in different data frames. Okay, so here's where the sort of money calculation happens. I won't run this now, but when I timed it, it was on the order of about 30 seconds. I did 2 years of data and I filtered to the top 25 athletes. So there would be 50 calls to BigQuery. And we use this glue function in R to basically say, take the year and the athlete name and create the query that looks right for them. And then, and this is sort of, again, a little bit more advanced, but once you sort of get the hang of this will be kind of addicting, is you use this future PMAP function. So PMAP allows you just to parallelize calculations in R. Future PMAP will take that and use multi-processing capabilities to do it in parallel. Essentially, you don't have to write the for loop. This will write the for loop for you and will scale across your different cores, in our case, 64. And again, for the purposes of our demo, I've already got this data here. But what you'll see here is that you get the athlete name and their Wikipedia views. And then we're back in the R world where we want to do some manipulation and group by date, find who is the most popular athlete. So in this case, what we'll do is across all the dates, which is now the last 2 years, 2019 and 2020 through the first 9 months, we will look at who ranks number 1 in terms of views. And then what we'll do is we will, so that can be done with this sort of rank function in R, and then we will look at who is number 1 the most days in the ranking. So if we go down here, you'll see No surprise. We kind of previewed this earlier. LeBron James was number one among these 25 athletes on 240 of the days in question. Tom Brady, another NFL quarterback, was 82, and Patrick Mahomes, we talked about, was number one on 45 of those days. And again, in terms of Wikipedia page views. So now we have an interesting result about who are among these people the most sort of famous on day-to-day basis. Of course, we can do averages. That could also be done in BigQuery. Of course, we can do more with plotting, and we could generate that same plot we did for every athlete here. And again, if I had more time, I would do that and then output all those to maybe cloud storage, and we'd have this whole like set of things we can look to. Again, exploratory data analysis, visualizing, transforming, thinking about things differently before we even get to the model stage is totally enabled here via our platform notebooks. So let's go back to our presentation here and wrap up. Okay, so hopefully what you took away from this talk is that R and Google Cloud together can help scale data science work. So we talked about BigQuery, scalable data in analytics, extremely large data, petabytes, up to petabytes of data. We actually showed what is relatively a small BigQuery data set just to illustrate the point. I've done many more crazy things with bigger data sets in BigQuery, and using R to kind of, again, I love R, but use BigQuery to be the workhorse up until the point where the data will fit in R, or I want to really, I really need it in R for my modeling or visualization, or something that can only be done in R. And then cloud storage, again, our sort of repository to put files in and out, store them, share them, kind of manage them. Super powerful tool for that. And finally, AI platform notebooks, interactive data science, and increased processing powers, kind of puts it all together, really well integrated with BigQuery, really well integrated with cloud storage. I didn't even go into the other APIs and things that are popular on AI platform and enable tons of different things. But hopefully this gives you an idea of how to use R on Google Cloud to do the data science you love doing and do it better, faster, and at greater scale. So thanks again for having me. Hopefully you found this talk useful, and feel free to reach out to me on Twitter or other means, and I'm happy to answer questions and talk about how to do great data science on Google Cloud.